Okay, so let's start with the first do now from week 3. The question says, based on the results of experiment 1, which of the following conclusions is valid concerning the effect of rain on new PVC? So if I flip back, 15 boards of new PVC were sprayed with distilled water for 10 hours a day. All 15 boards remained within 0.1 centimeter of their original dimensions. So that means that they were sprayed for 10 hours a day with water, but none of them really had cracking, bubbling, or degradation. So nothing really happened. So when it's exposed to rain, if we look through our answer choices, it doesn't permanently swell. There's nothing about acid rain. The material's surface does not appear to require a protective coating. So we know that based on the material, it doesn't really get water damage. So the answer choice is H. 23. Park benches in an often snow-covered region of Minnesota are to be replaced with new ones made of new PVC. The experimental results indicate that, and we already know that when it's covered in water, we don't see anything. So let's see what it's like if we have snow. Experiment 2 is all about the light, and then experiment 3 is about the weight. So let's look at our answer choices. A says the benches will suffer little degradation due to weathering. This one, B, the benches would have to be stored indoors during the winter to retain their initial strength. C, the benches should be varnished to prevent rain from seeping in. We know that that one's not valid because we already know that rain doesn't really have an effect. And then the benches will retain their initial flexibility. So Minnesota, if it's covered in snow, that means it's going to be cold. So let's go back to the experiment about temperature. Flexibility had decreased when they had a lot of ultraviolet light, which means that that is going to be when it's super sunny in the sun. We're looking through these. Go to experiment 3. These same boards were then kept for 32 weeks at temperatures ranging from 5 degrees to negative 15 degrees Celsius. That would be our winter temperatures. At the end of the experiment, the boards were able to support an average of only 400 pounds without bending. So we went from 963 pounds to 400 pounds without bending or breaking in the cold. So that means our answer choice is B. The benches would need to be stored indoors during winter to retain their initial strength. A reasonable control for experiment 1 would be a new PVC board submerged in distilled water, a new PVC board stored in a dry warehouse, a wooden board subjected to the same conditions, or a wooden board stored in a dry warehouse. So for here, we don't want it to be any different material because that's not a control for the new PVC. We want it to be something that isn't exposed to rain, so that means what's it like in the same amount of time just in a dry warehouse. 25. The purpose of the ultraviolet radiation used in experiment 2 was to what? So we actually already went over this, but on accident, and it's to simulate the effects of sunlight. So what would ultraviolet radiation do to the boards? From the information given, it can be inferred that new PVC's advantage over standard building materials such as wood is that what? It's heavier and denser, can be developed in different colors and temperatures, is less subject to structural cracking and failure, and is made from recycled plastic waste. So it still cracks and it still has the failures depending on the temperature, although this would be the second best answer because you think that's why you would use it. But the answer actually is J, because it doesn't tell us anything in the passage about structural materials, so we don't know what those are like. But what we do know is that this is recyclable, so it would be better for the environment. And they tell you that in this blurb here. A process that has been developed so plastic bottles can be recycled. So we don't know anything about wood and its resistance to failure, but we do know that this is better for the environment. And then 27. Which of the following experiments would be most likely to provide useful information concerning the weathering of new PVC? So, repeating experiment 1, increasing the length of the experiment from 32 to 64, investigating the effects of seawater and salt-rich air on the material, and then repeating experiment 3, decreasing the minimum from 15 to 40 degrees Celsius. So, if we go through here, investigating what's going to happen if it's by an ocean isn't really going to be or is going to be helpful. Increasing the length from 32 to 64 weeks, that takes it from half a year to just over a year, but we already saw that nothing really happens in 6 months. And then here we already saw that it goes down from 5 to 15, so we don't need to see what happens at 40 because we already know it decreases its strength by half. So the answer here is going to be A, 2 only, and this is why. So the conditions on the experiments already showed us extremes. It showed us extreme temperature, it showed us extreme sunlight, and then it showed us extreme water. So we don't need to make it more extreme, which is what these two answer choices would be, which means that it's only going to be 2 because we already know the extremes. This will tell us what it's like in a completely different environment, so A is your only option.